Hi, I'm JB Baker, the VP of Product and Marketing here at Scaleflux. Matt, who was intending to join us and be my co-host, has been called away to a customer meeting and won't be able to join us today. So we will go ahead and dive right in to should you care about your SSDs? So, not just to jump to the end, of course, we think you should care. But why? And we'll go through this a bit. And to help you get why the SSD matters, let's take a look at maybe, do your tires matter? If you're a race car driver going 150 miles an hour, trying to take every second out of every lap, of course, your tires are going to matter because you're looking for ways to take the corners faster, accelerate, decelerate faster, reduce how many pit stops you have to take. Now, for you as an IT manager or an infrastructure and operations lead, it's more about your servers and the high performance applications. And we're talking not seconds off of laps, but microseconds and milliseconds off of every action that your server is taking. So, back with the race car drivers, they look at their tires and there's different attributes of the tires that they can make trade-offs amongst. Grip, how they corner, the miles per gallon, how it contributes to the performance or the number of pit stops they have to take. Same thing on the tread life, how long those tires are going to last. And maybe not so much for the race car drivers, but for you as an individual, ride noise for your personal vehicle. And they have race car drivers have different types of tires represented here by the different gray bars. They're going to be optimized for one or more of these particular attributes. So in NASCAR, they have super speedway tires that need more durability and tread life because it's a longer track. And then they have road course tires that are more optimized around handling because they have to turn right and left instead of just left. Now, but a lot of the tires are basically the same. And also, if you are driving not on the racetrack, but in bumper to bumper traffic, you're probably not going to notice a lot of difference between the attributes of those tires. Same thing if you're just driving the kids to school and you're driving in school zones. Hopefully, you're not speeding through. You're just following the speed limits. And again, you're not going to notice much of a difference amongst those tires. And that's what we hear a lot about SSDs is there's just not a lot of difference. But now, what if we could take those tires and suddenly get twice the benefit from each one of, or on each of these different attributes? You could take your corners faster. You get twice the distance per tank of gas. You don't have to stop to change tires only as frequently, only half as much. And they're awfully quiet, so you don't have to crank up your stereo to hear it. Well, that's what Scaleflux does for SSDs. Only instead of ride noise and miles per gallon, we're talking about your mixed read write performance, how responsive your applications are, the performance per watt, how much work you're getting for every watt of energy you're putting into your server or your data center, the endurance of the drives, how long they can last, how many terabytes and you can write over the lifetime of those drives over 3-5 years or longer. And then the latency, that responsiveness, are they consistently low on the latency? And yes, I know that the bar is higher here, but the idea was that it's twice as good on the latency, that you're getting better latency consistency and lower latency. So that's what we're doing with the SSDs, is making a difference with the Scaleflux SSD versus what you see from every other enterprise NVMe SSD out there. And the feedback we get from the customers is, hey, the Scaleflux SSDs make it easier for me to meet my service level agreements. I get lower and more consistent latency so that I can keep my customers happy. It helps me meet my efficiency performance indicators by, again, improving that performance per watt, improving that efficiency that you're getting out of every watt of energy, which then transfers not just from the drive, but then to the server and the cooling. And then helping me improve my overall uptime. This one's it's kind of a second order benefit, but we're reducing how much equipment is needed to deliver a certain level of work. So we'll go step ahead here into a handful of case studies from actual customers. So we've got an example here from a financial services company that is doing packet capture. This is capturing and analyzing all of the market tick data as it's coming across, and the volume of this just continually increases, and they need to do this faster and faster. And so there's significant challenges around the latency. The drives have to be extremely low latency on the writes, as well as providing low latency on the read at the same time so they can perform those real-time analytics. There's extremely high performance demands on this, and it's a mix of read writes, so they can do the analytics on the reads and capture the data on the writes. With the heavy write workload, they are worried about the endurance of the drives. And then they're also worried about how much it costs them to build the clusters to service this application. Now, putting in the Scaleflux drives, what they report is, hey, I just plugged this thing in, and without changing the application, I got better latency and better latency consistency. I get 2 to 4x the performance per drive, kind of depending on what that read-write mix is. The drives, I check on the lifespan on the drives, and it's 9 times what I'm getting from other drives because of this application. And then not only do they get all of those performance and endurance benefits, but they're able to reduce the cost of the storage itself by storing more data per drive that they put into their infrastructure. Moving on to a different application. So we have uCloud that has a massively parallel file system to service customers for cloud storage. They're doing AI training, EDA simulations, graphics rendering, and many other applications. You're going to start to see some redundancy here in the problems, but they see that it costs them a lot to provide that data resiliency. So they do triple replication to make sure that if something fails, that they can always have that data available for their users. And then latency is super critical for them as well, because they have service level agreements, and that's what they're selling their services on as well. And then as they're rapidly growing the number of users and the amount of data per user, they have to scale the performance to manage all of these new users and provide, again, meet those SLAs. They plugged in the Scaleflux drives, and what they found was they could use the compression that's built into the drives to dramatically reduce the deployment cost. So they're storing twice the amount of data per drive. They lower their deployment cost, not just on the drives by 40%, but also on the number of systems. So they reduced how many servers they needed. They reduced the power that they needed to deliver that service. And at the same time, it improved the access latency, reduced their latency from 150 microseconds down to 90 microseconds. And they found that with the performance attributes of the drives, it was easier for them to scale performance to add new users within an existing system, just simply because of the performance attributes of the SSDs that they put in there. Another cloud scale application here with Alibaba and their PolarDB, which is a hybrid transactional analytical database. And they've got thousands of customers across hundreds of countries and regions, so a massive scale database here. And again, they've got the pains around the cost of the infrastructure, how much power it takes to deliver this service, and then the high maintenance cost and the data center space that is needed to provide these services. Plugging in the Scaleflux drives, they saw a 60% reduction in their overall deployment cost. They're taking the drives to 2.5 times their raw capacity by, again, leveraging the data compression that's built right into the drives. And that reduces, again, how many servers they need, how many racks they need, how much power it takes to deliver that service. And so that saves them a lot of money on delivering the service, allowing them to increase margins and gain market share. And then it also reduces that data center floor space. And then by having fewer systems, it just makes your overall infrastructure simpler. As you start to scale out, you start to see an increasing or a kind of a exponential increase in the complexity of management as you double and quadruple your number of systems. Another example here, a smaller another application on a relational database. We have a very large scale customer who does Postgres as their primary application, and for IT services and IT operations management for their customers. Again, same types of problems, the cost of the infrastructure to deliver this service, the challenges around service events when a component in their infrastructure fails. And then again, struggles trying to meet the latency requirements of their applications. So plug it in the Scaleflux drives. Once again, right away, they see the reduction in storage costs by being able to use the compression capability in the drive to extend the effective capacity per drive. It simplifies their infrastructure by using half as many drives. That doubled their reliability. Half as many drives equals half as many failure opportunities. And then all of that, again, without impacting the user experience. So that compression function happening in the drives and the reduced number of drives, well, the increase in performance in the drives offset any potential impacts to the user experience. GMO Cloud is a customer over in Japan, and they provide a cloud-based MySQL operation. Again, they with standard drives, what they had was a much more complex infrastructure with a high number of components. They saw a high cost of providing that resiliency for the users, and again, having to put more systems in place in order to meet the latency requirements as their number of users grows. They plugged in the drives, and what they saw was more, even bigger benefit there. They cut the number of drives by 3/4, and that also allowed them to cut the number of servers in half to achieve the same number of transactions per second. So to deliver a given service level, it cost them half as many servers and 3/4 or 75% reduction in the number of drives. That dramatically reduces their deployment cost and again allows them to maintain that customer experience. So that helps them in their business goals of being a profitable enterprise. Now, how are we doing this? I mentioned throughout there the compression in the drive, but basically, what we're doing is taking all of the features that you find in a standard enterprise NVMe SSD, standard form factors, standard drivers, standard capacity points, physical capacity points, all of the encryption and data protection, data resiliency aspects, security aspects that you expect in your enterprise SSD. And then we've innovated. In our controller that we designed, we added in computational storage engines. And in particular, these are hardware-based compression engines that are transparently compressing the data as it's written to the drive and decompressing the data as you read it back. So there's nothing the user has to do to turn that on. It just happens. That's why we put simply there as well. And then the variable length map FTL, we had to make refinements to our flash translation layer to be able to handle the variable size of data that comes out of being compressed. The ordinary drives out there have a fixed length FTL because every chunk that comes through is exactly the same size. So it's just a complexity that we had to work through over our first 3 generations of product to refine it and make it perfect. And the result of that is the better NVMe SSD. It's designed for ease of use. We understand that the users just don't have the time to go and learn something new on how to install a different kind of drive and manage it and put in different drivers and modify your applications. So we designed this to be easy. You plug it in, we're using the NVMe standard drivers, we're using NVMe standard commands. There's no application integration you have to make. You don't have to change things in your application to take advantage of this compression. And then that compression happening transparently in the background improves the SSD efficiency. So you get more IOs per second, more endurance per terabyte of NAND that you buy, and more effective capacity, or terabytes effective per gigabyte of flash that you buy. And then all of those attributes in the drive help translate into better system efficiency and application performance, as we just went through with the customer examples. Now we get questions around, all right, compression, how is it possible that that improves performance? Because everybody has the history of using software compression, running into CPU, and even LZ4, lightweight compressor, slows things down, can add latency, and detract from the CPU cycles that are available to running the application. And if you try to do a gzip level compression like we do in the drives in software, man, things just grind to a halt. So how is it possible that it improves performance? Well, in this chart, what I'm showing here, the red line is SSD endurance, and then the gray line is the write amplification, or how many gigabytes of data the SSD controller ends up writing to the flash for every gigabyte of data that you send it from the host. This happens because the SSDs have to manage data that has been deleted and move things around in the background. So it's not just, hey, I sent data to the drive and it was written. That SSD controller is like that duck paddling across the lake, the feeder turning like crazy underneath as it's moving data around to create free space to write new data, clean up data that's been deleted, and do all of that garbage collection activity in the background. So on the y-axis there is write amplification, and as it's and the x-axis is over provisioning. So how much free space the drive is hiding from the user. So when you buy a 3.84 terabyte drive, it has more than 3.84 terabytes of physical NAND on it. Typically, it has 4 terabytes of NAND on that drive. And that difference between the 384 and the 4 terabytes is the over provisioning, or how much NAND is kind of hidden from the user, so the controller can use that in the background to keep things clean. So now the difference here, when you buy a 7.68 terabyte drive, that's got 7% OP, and the write amp is going to be on the order of 4.5. Each controller is a little bit different, each drive is a little bit different, but right about 4.5. And that's your 1 drive write per day class drive. When you buy a 6.4 terabyte drive to get 3 drive writes per day, to get that extended endurance, to get better performance, that's going to have a write amp around 2.5. It's also going to have, both of these drives are going to have 8 terabytes of physical capacity, and you're just trading off usable capacity to get better performance and better endurance, because you're reducing that write amp in the background, which is detracting from what you can use on the for the application side. Now, when we get data to compress just 20%, that same 7.68 terabyte drive can perform and have the effective write amp just like that 6.4 terabyte drive. So because in the background, we effectively have the same amount of free space, 28% free space. We get up to the 2.2 to 1 compression, and now suddenly there's always free space for the drive to write new data to. Because when you've written 7.68 terabytes of data from the host, it's only consumed 3.84 terabytes of physical capacity on the drive. So there's always free space available. And this is where we get the write amp down underneath 1. And that's how we get to that massively extended endurance. So when you're going from a write amp of 4.5 down to a write amp of, say, 0.5, that's 9 times the endurance. And then what we also see is that your ordinary drives all have a graph that's going to look like this. The absolute value on is going to vary a little bit, but if you've tested drives, you're going to see, hey, I plugged it in and I started writing to the drive and I got awesome performance, right? 700,000 random write operations. But then after an hour, the drive started to fill up and my performance tanked and just got down to what we call that steady state performance that's running in this chart around 200,000 random writes. And that's very typical, right? If you take a drive from any vendor and you're going to get a graph that's going to look very much like this. You take the Scaleflux drive with the compression built in and you avoid that cliff diving. You can run along here and the drive, while it looks like it to the host like it has logically filled up, on the back end, as I showed on the prior page, it's never actually full. So the controller has free space to write data and is able to continue to provide you that extremely high performance all the way up to 100% full. So, kind of in conclusion, a handful of additional customer quotes here. They're all echoing the same things as they plug in the drives and they see the performance benefits. They are able to stop making trade-offs between performance and endurance. They're able to fill the drives to a higher percentage. They don't have to stop at 60 or 70%. They can run them up to 80, 90, 95% full before having to install additional capacity. They see that the drive attributes do transfer over into application benefits when they're pushing those applications hard and they're trying to get the most out of that expensive infrastructure. All those CPUs and GPUs and DRAM that they're running, you want to get the absolute most performance out of that. You need storage that can keep up. So that is why you should care about your SSDs, or why it matters again. I can understand that with all of the other drives out there that it didn't make a lot of difference, because that you might have been plus or minus a handful of percentage points on the random reads or the latency. All the endurance is all about the same. You've got your 1 drive write and your 3 drive write per day class drives. So it really didn't matter what brand you chose. But now with the Scaleflux innovative computational storage drive with the transparent compression, you can start to double all of those attributes, and it can make a difference to your overall infrastructure. And like always, I don't expect you to just take my word for it. So do reach out to us, contact us for samples. We do also have a compression estimator tool, so you can run your data through that and identify how compressible data is in your environment. With that, I will open for questions. And I do see we've got one here already. What is the capacity available in the E1S? So we have 4 and 8 terabytes available in E1S. There's not as many places to put NAND on that smaller form factor, so we can't go to higher capacities. Let's see, can we get a copy of the presentation? Yeah, absolutely. Send me a message, or send a message to the info@Scaleflux, and we can get you a copy of the information. Is a drive just using compression or compression plus dedupe? It is just compression. So we are doing block level compression. Every 4K chunk of data that comes in, we compress that. Dedupe is dedupe we leave, or is much more intensive, and we would leave that to your storage arrays to try to do file level deduplication. At a 4 or 8 terabyte or 16 terabyte capacity, there's not as much opportunity to do dedupe. Does this work for other applications? Absolutely. I just showed a handful here, but we have several other examples with, let's see, RocksDB, AeroSpike, ScyllaDB. Trying to think here. Oh, media streaming, where even though the data wasn't very highly compressible, the all of the metadata is still compressible, and that allowed for that lower latency on first bytes read back from the drive. So even for a media streaming application, we saw significant benefits. And if I haven't mentioned your application, again, just shoot us a note, and we can take a look and help you test and figure it out. How do I know if my application will benefit? So a couple of things here. One, if the data has any compressibility in it, even just that 1.2 to 1 compression, you're going to see better performance out of the drives than you will out of an ordinary NVMe SSD. But that's not the only thing. If you are running your server at just a very low level and not pushing it at all, you're probably not going to see a significant benefit. But if you're trying to get the most out of your infrastructure and you're pushing your servers and you're trying to add more users and try to get more transactions per second or analyses queries per second completed, then you can see a significant benefit. How can compression make things faster? That doesn't make sense. So I did touch on this a bit, but the compression, basically, we're doing it in hardware. So it's a hardware state machine, which can just compress the data at line rate as we're going through. So that's how it's different from what you might have experienced in the past of using a general purpose processor to run your compression with a software application. General purpose processors are not that great at doing compression. There's a lot of reading and writing and storing and caching of the data. So that iterative process consumes a lot of CPU cycles and slows things down. When we do it in a hardware engine, it's a state machine and it happens super fast because it's the same task over and over and over again. So there's that aspect of the hardware engine is better than doing it in a CPU and much more efficient. And then the other aspect of it is that increasing the effective free space that we have on the back end to reduce the write amplification and reduce the instances of trying to write to and read from the same die at the same time and having those actions blocked, and also being able to use all of that write bandwidth down to the drives for actually writing new data, writing the hot data, instead of having to use a significant portion of that capability to rewrite cold data as you move it around as for garbage collection. Other questions? Okay. I guess that we're out of time. We're right at the 30 minutes. Thank you very much. Again, reach out to us at info@scaleflux.com. Also, I forgot to mention there is that QR code in the upper left that you can scan to get right to our request a free consultation page. And thank you for showing up. Have a great day.